Okay, so today's lesson is on trigonometric identities. I know that this lesson is from your Unit 5 booklet, which is where you're going to go to take a look at this lesson. So you need to open up the Unit 5 booklet that I gave to you. This will be on the next test that will be before the Christmas break. So we're adding it onto that unit instead, since I wasn't there on Monday. So take out your books, open up to 5.5 trig identities. Now, for trig identities, first thing, what is an identity? Well, an identity is a mathematical statement that is true for all values of the given variable. If the identity involves fractions, the denominator cannot be zero. This is very important, okay? Any restrictions must be stated. So I know we've discussed about restrictions before. So remember, restrictions have to be stated in these as well. Anytime a denominator is zero, you must state the restriction. Now, in trigonometry, some trigonometric identities are a result of a definition. Others are derived from relationships that exist among trigonometric ratios. To prove that a given trigonometric equation is in fact an identity, let me just do this for a minute, sorry. To prove that it is in fact an identity, okay, both sides of the equation need to be shown to be equivalent. Okay, very important right there. Just give me a second. Now, some useful strategies. Simplify the more complicated side, okay, until it is identical to the other side, or manipulate both sides to get the same expression. This is a simple tip or strategy you can use. Rewrite all trig ratios in terms of x, y, and r. Now you should remember x, y, and r from last unit. When we did sine, cos, and tan, we wrote them as x over y, y over r, and so forth. Okay, you need to remember those trig ratios for sine, cos, and tan, how you write them as x, y, and r. Then rewrite all expressions involving tangent and the reciprocal ratios in terms of sine and cosine. So remember this, anytime you see tan or reciprocal ratio in a question, you must rewrite it, okay, in terms of sine or cosine. And I'll show you what this means in a minute. Then you can apply the Pythagorean identity wherever it's appropriate, okay? So I'm gonna explain what the Pythagorean identity is, but if you do see it in a question, okay, you must apply this identity. And finally, you also use a common denominator or factoring if it is required, okay? Now this lesson is quite difficult, one of the ones that students have most difficulty with, so this is very important right here. The most important strategy of all is patience and perseverance, okay? So if you get stuck, start again and with a different outlook and plan, okay? So you may have to start again at times, but that's not a problem. Oops. Okay, so let's move on. Now, your reciprocal identities, okay? Reciprocal identities, we've seen these before, okay? These are your cosecant, secant, and cotangent. This is the reciprocal of sine, the reciprocal of cos, and the reciprocal of tan. Anytime you see cosecant, secant, or cotangent, you must convert them into their reciprocal. So you must write them as 1 over sine, 1 over cos, 1 over tan, okay? Quotient identities. So this is a quotient identity. This is stating that tan of theta is equal to sine of theta over cos of theta. The whole point of trig identities is to prove that what is being said is actually true, that the left side is equal to the right side. So we would write it like this. Oh, 1 second. Let's see if this works. Okay, so let's go back. Okay, so left side is equal, okay, to tan of theta, and we have that the right side is equal to sine theta over cos theta. So remember, always start with the most complicated side. The most complicated side in this scenario is the right side. So let's start here. So our right side, remember, convert sine, cos, or tan in terms of x, y, and r. So if I convert this into x, y, and r, based on what we did previously, or what we've learned, we know that sine is y over r, okay, and then cos is x over r. Okay, so y over r divided by x over r. So if I rewrite this to make it look like multiplication, when you multiply fractions, you multiply by the reciprocal. So y over r, okay, is multiplied by r over x. Now, because you're multiplying by the reciprocal, right, you would multiply and rx. So you would get yr over rx, and then the r's cancel each other out. So then you are left with y over x. Now, if you go to tan on the left side, well, tan, when you write it in terms of x, y, and r, it is, in fact, y over x. So there you have proven that this ratio, or this identity, is in fact true, that tan is in fact equal to sine over cos. So this is something you must remember. Tan is essentially sine over cos as well. Now you also have to state your restrictions. So take a look at whenever you have sine, cos, or tan, whatever's in the denominator. So on my right side, I have cos theta in my denominator. Okay, so when I have cos theta in my denominator, I must state what theta cannot be in order for my denominator to be 0. Now, if we go back to, if you remember the unit circle or the sinusoidal functions, okay, 0, 90, 180, 270, 360, what degrees caused cos to be 0? Now, you can also think of the cos function as a graph, okay? When did cos equal 0 from the parent function? Well, we remember that cos was 0 when at 90 degrees and as well as 270 degrees. So therefore, theta cannot equal, okay, 90 degrees or 270 degrees, okay? And we can conclude this by saying, therefore, our left side is equal to our right side, okay? Now, don't forget, okay, this is all because of the unit circle. This right here, okay, is because cos at 90 and 270 equals 0. And you cannot have 0 in the denominator, okay? So, let's move on to the next one. Prove this quotient identity. So now I must prove this. Again, I must state what my left side is. So my left side is cotangent theta, and my right side is cos theta over sine of theta. Okay? So now, if you go back to what we remember we said anytime you see a reciprocal ratio, always convert it to what the actual, or convert it in terms of sine, cos, or tan. So this is cotangent. In terms of tan, this would be 1 over tan theta. Now we have it as 1 over tan theta. Let's start with this side, okay? Cos over sine. Let's convert this now into in terms of x, y, and r. So cos as x, y, and r is x over r, and then that's over, since sine is y over r. Okay? Now, if I go ahead and do this, again, let's multiply these. So this would be x over r being multiplied by the reciprocal, which is r over y. Again, the r's cancel out, and I am left with x over y. Now, take a look at this. 1 over 10, let's convert 10 in terms of x, y, and r. Now 10 as x, y, and r is y over x, okay? And 1 over a fraction, this is basically telling you it is the reciprocal, so I can just flip these two, which means this is now x over y. And in fact, we can see that the left side is in fact equal to the right side, so we can say therefore left side equals right side. We must state our restrictions. Theta cannot equal, well, let's take a look at what's in my denominator. Well, sine is in my denominator here, and tan is in my denominator here. Remember, restrictions, you have to look at all your steps and see what is in the denominator of every single step, okay? And that determines your restrictions. So sine and tan are my denominator. Now, I know we didn't graph any tan functions, but if you remember from the unit circle, okay, you will remember that tan was, I believe, 0, undefined, 0, undefined, 0. So because it was 0 and undefined, essentially, all the degrees of 0, 90, 180, 270, 360, those all produce a 0 or undefined denominator, in which that must be our restriction, okay? So theta cannot be 0 degrees, 90 degrees, 180 degrees, 270 degrees, or 360 degrees, okay? And this also covers sine, because for sine, sine is 0 when it's 0, 180, and 360. If you remember the sinusoidal graph or the sine graph, it was on the, apologize. Yeah, 0, 180, and 360 is when it's 0, okay? So, let's go on to the next one now. Again, this is something you also must remember. These are things you must memorize. Since this is true, cotangent is in fact equal to cos over sine, okay? Okay, now this is the Pythagorean identities that I was telling you about, that when you see these identities, you must follow the rules for them, or you must convert them. So again, we're going to prove this identity is in fact true. So in order to prove this identity is in fact true, again, I must prove that the left side is equal to the right side. So in this case, my left side is equal to sine square theta plus cos square theta. And my right side is simply equal to, my right side is simply equal to 1. Okay, so my left side is this, my right side is this. So now, left side, let's convert this into our x, y, and r ratio. So sine was y over r, and this is saying that it's squared, plus cos, which is x over r, again squared, okay? So y over r squared plus x over r squared, remember the exponent gets applied to numerator and denominator, so this is y squared over r squared plus x squared over r squared, okay? So now, when I add these together, I have a common denominator, therefore I can add my numerators. Although they're not like terms, I can write them with one common denominator. So this is just y squared plus x squared over r squared. Now, take a look at the numerator. Y squared over x squared. What does this remind you of? Okay, this should remind you of the Pythagorean theorem. X squared plus y squared equals, a squared plus b squared equals c squared, or in terms of x, y, and r, remember we used r squared is equal to x squared plus y squared. Remember the Pythagorean, okay, theorem. X squared plus y squared equals r squared. Okay, so because that's the Pythagorean theorem, we can say that, well, x squared plus y squared, or y squared plus x squared, okay, is a Pythagorean theorem, then this is equal to r squared, so this must be r squared over r squared, which is equal to 1. And again, I have my left side equaling my right side, so this is in fact true. Now, there's no restrictions in this case because I don't have any denominators, okay? My r is right there, but r is equal to 1, so I have no restrictions. Okay? Again, this is something you must remember. Sine squared plus cos squared is equal to 1. You must also remember the rearrangement of each of these. So the rearrangement is 1 minus cos squared is equal to sine squared theta. Okay, sorry, I forgot to put theta here. So 1 minus cos squared theta is equal to sine squared theta, or 1 minus sine squared theta is equal to cos squared theta. Okay, so you must remember this as well as this. Okay, those are the Pythagorean identities. Now I have I have two more Pythagorean identities to go over with you. So we'll go to the next one. Okay, so here's another one. 1 plus tan squared is equal to secant squared. So again, I must prove that my left side is equal to my right side. So left side is equal to 1 plus tan squared theta. And my right side is secant squared theta. Now, remember what we learned, or what I said at the beginning. Always convert tan in terms of sine or cos, and always convert your reciprocals in terms of the ratio, what they would be as sine and cos. So let's go to here. 1 plus tan squared theta. If we go back, okay, you should remember that one of the quotient identities that we've done, our first example, our first quotient identity was tan squared is equal to sine squared, sorry, tan is equal to sine over cos, okay? Remember that. So now that I know that that is in fact true, I can write this, instead of writing as tan, as sine over cos. Because it's squared, okay, it doesn't matter. Now I could just write it as sine squared theta over cos squared theta, because essentially tan is sine over cos. Tan being squared would just be the fraction squared. Now, because this is a fraction being added by a whole number, we need a common denominator. Okay, so therefore, this is technically over 1. I'll just write this here. Okay, need common denominator. Okay, so well, in order for this to get a common denominator, I would have to multiply both the numerator and denominator by cos squared theta. So this would be cos squared theta, okay, over cos squared theta, and then we would plus sine squared theta over cos squared theta. Okay, so now I have a common denominator, so then I could just combine this and write this as cos squared theta plus sine squared theta, okay, that is all over cos squared theta, okay? So now, take a look at this denominator. Does this look familiar to you? Cos squared theta plus sine squared theta. What did we just discover that this is? If I go back, cos squared theta plus sine squared theta, that was equal to 1. So therefore, I can replace this with 1. Okay, this was my Pythagorean identity. So this is now 1 over cos squared theta. Now, let's take a look back here at my right side. So my right side is secant squared theta. So secant, we have to turn in terms of sine, cos, or tan. And secant is the reciprocal for cos. So normally it would be 1 over cos theta, but because it's squared, all it means is 1 over cos squared theta. So now you can see that my left side is equal to my right side. Therefore, I prove this to be correct. Left side is equal to right side, and I must also state my restrictions. So if I take a look, what is in my denominator? Well, the only thing I have in my denominator all throughout here is cos. So I have to think, well, what does cos, what degrees out of 0, 90, 180, and 360 does cos equal 0? In this case, again, it is 90 and 270. Okay, again, because of cos. Okay, because of cos in the denominator. Okay, one more Pythagorean identity. So the last Pythagorean identity is 1 plus cotangent squared is equal to cosecant squared. So again, left side, we have to prove that our left side is equal to our right side. So left side is 1 plus cotangent squared theta, and my right side is cosecant squared theta. Now, 1 plus cotangent squared theta, again, I must convert this reciprocal ratio into what it is in terms of sine, cos, or tan. This is the reciprocal of tan. So this is in fact 1 over tan squared theta. Same thing, we need a common denominator, okay? However, before I figure out a common denominator, I must, even though I converted this into its reciprocal ratio, the other key thing that I need to remember is anytime I see tan, I must convert tan into, in terms of sine or cos. So again, one of the first quotient identities that we talked about was that tan is equal to sine over cos. Now, because this is the reciprocal, instead of writing, okay, 1 over sine over cos, I can just flip sine over cos and write it as cos squared theta over sine squared theta, okay? Again, normally tan is equal to sine over cos, but because we have 1 over tan, that means it's the reciprocal. The reciprocal means you flip the denominator with the numerator. So instead of sine over cos, this is now cos over sine. And because it's squared, you can square both as well. Okay, now we need a common denominator. So again, this would just be sine squared theta over sine squared theta. Let me just move this down. Plus cos squared theta over sine squared theta. Okay. Now again, this is common denominator, so I'm left with sine squared theta plus cos squared theta all over sine squared theta. Now, again, this should look familiar to you. This is again the Pythagorean identity, okay? Pythagorean identity. So therefore this is equal to 1. So I'm left with 1 over sine squared theta. Okay, now let's go back to my right side. Okay, so my right side is cosecant squared theta. So cosecant is a reciprocal of sine. So let me write that in terms of sine. So that means it's 1 over sine theta. Again, because there's something squared, we can write squared right there. So therefore, there I have it. My left side is equal to my right side. Okay, therefore, left side is equal to my right side. And I need to state my restrictions. Okay, theta cannot equal, we'll take a look at what's in my denominator. Okay, in my denominator, I have sine. Okay, in all these denominators. Remember that this is in fact in terms of tan. Okay, so therefore it would be 0, 180, actually sorry, including tan, it would be all of them. 0, 90, 180, 270, and 360. Okay, so it's all of them because tan is in the denominator, even though sine is in the denominator as well. Um, it's 0, 90, 180, 270, and 360. Okay, again, this is something you need to remember. So let's move on to the next page. Now, important trig identities. Now these, yes, you will have to have them memorized. You will not get these on your exam or on your test. Okay, these you should already know. You know that cosecant is 1 over sine, secant is 1 over cos, and cotangent is 1 over tan. These are the new identities that you have discovered that you need to remember. So these are the quotient identities. Tan is equal to sine over cos. Anytime tan is squared, you can just have these sine squared over cos squared, okay? If tan is in a reciprocal and you need to convert this, this is now cos over sine, okay? However, you need to remember this. Cotangent, okay, is actually cos over sine. So there you go. Cotangent is cos over sine, so that is the reciprocal of tan, okay? And in this case, cos cannot equal 0, and in this case, sine cannot equal 0 as well. Pythagorean identities, sine squared plus cos squared is equal to 1. Don't forget how they are when you rearrange them. Don't forget 1 minus cos squared is equal to sine squared, and 1 minus sine squared is equal to cos squared. You need to remember the rearrangement of these as well, because that's proving, those are proofs also, okay? 1 plus tan squared is equal to secant squared. You must remember that. And 1 plus cotangent squared is equal to cosecant squared. Okay? So again, these are ones you must remember, as well as if you had any rearrangement of these. For example, if you had secant squared take away 1, that would equal tan squared as well. Okay? So you need to be able to remember all of these identities, Pythagorean identities and quotient identities, okay? Now, the reason being is now because we are going to prove different questions. So you're proving that your left side is equal to the right side. And when you're proving, you can't just give up and say the left side just does not equal the right side. There is a way. If you don't get it the first time, erase what you've done and try again, okay? You are going to have difficulty. I'm going to tell you that you're going to have multiple times where you're going to have to erase what you've done and then just try again. Like I said at the beginning, you have to be patient with this, okay? So let's prove this right here. Actually, one more thing, let me just go over this with you. Don't forget, for sine, cos, and tan, sine is 0, okay, when it is at 0 degrees, 180 degrees, and 360 degrees. We must remember this, okay? Cos of theta is equal to 0 when it's at 90 degrees and 270 degrees. And then tan is 0, okay, when it's at everything, 0, 90, 180, 270, and 360. Okay, now this is important for when you're talking about the restrictions, okay? Okay, prove each of the following. So tan theta times cos theta is equal to sine theta. So left side is tan theta, okay, times cos theta. And my right side is sine theta. So tan theta multiplied by cos theta. Remember, we must always convert tan in terms of sine and cos. So tan is sine theta over cos theta. Okay, and this is being multiplied by cos theta. So when I'm multiplying, remember I'm multiplying numerator, denominator with denominator. This is technically over 1, right? So sine times cos, you're left with sine theta times cos theta all over cos theta. And there you can see that cos actually cancels out and you're just left with sine theta. So therefore, my left side is in fact equal to my right side. And my restrictions are based on cos, and since they're based on cos, because cos is the only thing in the denominator, theta cannot equal 90 degrees or 270 degrees. Okay? Okay, let's move on to the next one. So, let's do B. Okay, prove each of the following. Let's start off with my left side. Left side is 1 minus cos squared theta over sine theta, okay? And my right side is sine theta. Now, if you remember, okay, 1 minus cos squared theta, this was, okay, the Pythagorean identity just rearranged. So this was sine squared theta plus cos squared theta, okay, equals 1. Rearranged, sine squared theta is equal to 1 minus cos squared theta. So therefore, this must equal sine squared theta. So sine squared theta over sine theta, okay? Basically, all you're doing, well, this is going to eliminate one of the signs that's up here, okay? So this cancels one of the signs, so I'm left with just sine theta. And now you can see that my left side is in fact equal to my right side, okay? And I must state my restrictions. Theta cannot equal 0 degrees, 180 degrees, or 360 degrees, and that is because sine is always in my denominator. Okay, let's do C. Okay, so again, we do prove that our left side is equal to my right side. Okay, left side is cosecant of x. Now, x is just another variable used for the degrees. Don't worry that it's not theta. And then secant x, and my right side is cotangent x. Now, notice how I write left side separate from my right side. Please do not work on these simultaneously. You will lose marks per form, okay? Don't just write out what you can convert this and set it equal to what the right side is. You must have them separate. Left side is equal to this, and on this side, right side is equal to this. It must be separate. I must tell you that. Okay, it's imperative. You will lose marks. Okay, so let's convert these in terms of sine, cos, and tan. These are reciprocal ratios. So this is actually 1 over sine of x over 1 over cos of x, okay? So basically, that is the same as saying 1 over sine of x multiplied by, remember, this is division, so when I'm multiplying by the reciprocal. So I'm multiplying it by cos of x over 1. So I'm multiplying these two together. So I have cos of x over sine of x. Okay, so now let's go here. Cotangent is in fact 1 over tan of x, which, remember, cotangent, okay, as a quotient identity is actually cos, okay, over sine. So therefore, my left side is in fact equal to my right side. And I must state my restrictions, okay? Theta cannot equal, okay, well, basically I have cos in my denominator, and I have sine in my denominator here, but I also have tan in my denominator here, so therefore it's everything 0, 90, 180, 270, or 360, okay? Okay, now let's take a look at another example, okay? Let's take a look at D. Now, Tan x times cotangent of x is equal to secant x times cos x. So left side, okay, tan x, okay, times cotangent of x, and my right side is secant x multiplied by cosecant of x, okay? So let's start on my left side. Tan has to be, sorry, actually, yeah, let's start here, okay? Tan x, okay? Cotangent gets turned in terms of its reciprocal ratio, which is 1 over tan of x. And if I multiply these two, I have tan of x over tan of x, which is actually equal to 1, okay? Some of you are probably wondering, well, why didn't you turn this in terms of sine or cos? Okay, because tan x is sine over cos, and this is cos over sine. Okay, and when I multiply the two, in that case, it'll still work out, but this is a little bit faster as well. You can see that this works. Go ahead and do that. Okay, secant is 1 over cos of x, okay, and this is being multiplied by cos x. Now remember, this is technically like a whole number, so it's technically over 1. So when I multiply the 2, I'm left with cos x over cos x. And those they don't cancel each other out. Well, they do essentially, and it's equal to 1. Okay? So because those are both equal to 1, my left side is equal to my right side. Again, some of you may change it to different things, and in that case, it's trial and error. You have to just keep trying until your left side is equal to the right side. Okay? Let's do the next example, E. Okay? Again, left side and right side. So my left side in this case is tan theta. Oh, sorry, one more thing I forgot to do. I forgot to do my therefore statement. Left side is equal to right side, and I forgot to do my restrictions. Theta cannot equal in this case because tan is at the denominator. It's everything. 0, 90, 180, 270, and 360. Okay, so here we go. Left side and right side. So this is sine theta plus sine squared theta over cos theta, cos theta, let me just erase that. Cos theta, okay, times 1 plus sine theta. Now, let's work with my right side. It is my more complicated side, okay? So this is important here. In one of the steps at the beginning, I talked about also looking to see if there's anything you can factor, okay? So up right here, okay, you can see that in here you have a greatest common factor, and in this case you have a greatest common factor that is sine theta. So if I remove sine theta, okay, I take out the greatest common factor, I'd be left with sine theta, okay, bracket, well, sine theta divided by sine theta is 1, and sine squared theta divided by sine theta is sine theta, okay? That is all over cos theta, and then 1 plus sine theta. Now you can see that 1 plus sine theta and 1 plus sine theta can cancel out, and then you're left with sine theta over cos theta, which essentially, if we go back to the left side, tan is sine theta over cos theta. So my left side is equal to my right side. Now some of you are thinking, how am I going to see this? How am I going to see that this is, factorable? Well, remember, the whole purpose is you want to try to get your left side to equal to your right side. So if you knew that this was tan and then sine over cos, somehow you would try to get this to sine over cos, okay? And in order to do that, you can see that there's a sine over cos here, and you think, well, what can I do to make this something on my numerator have this right here in order for it to eliminate one another? Well, I took a look, and in fact, I can factor sine out because it is the greatest common factor. This takes time and patience, okay? This is what I'm saying. You're going to have to practice. You're going to have to do this over and over again. Don't give up, though, okay? So again, therefore, my left side is equal to my right side, and theta cannot equal 90 degrees or 270 degrees. This is because cos is in my denominator, okay? It doesn't matter that sine's here. Some of you are thinking of that because even if sine was equal to 0, okay, you're adding 1, so 0 plus 1 is 1. So that doesn't matter, okay? It's whatever's being multiplied. This cos, if this was 0 and it multiplied to this bracket, it would make the whole denominator 0, okay? Okay, another one. Example F. Okay, this is our last example. Okay, again, this is going to include factoring. Now, let's start off with my left side. My left side is 2 cosecant squared. So this means 2 is being multiplied by cosecant squared. Okay, x. And then my right side is 1 over 1 minus cos x plus 1 over 1 plus cos x. Okay, so let's take, again, these are two complicated sides, so we can either work on one at a time or you can work on them simultaneously. In this case, maybe let's work on them simultaneously. So this is in fact 2, okay, and 2 is, remember, cosecant squared is in fact one of the identities, okay, one of the Pythagorean identities, which is 1 plus cotangent, okay, 1 plus cotangent. This was this because of one of the identities, okay, so this got converted. You have to remember your identities. Now, cotangent I have to convert, okay, to its reciprocal ratio, 1 plus 1 over 10, because cotangent is reciprocal of 10, squared x, okay. Now, I can't leave 10 there. I need to convert that in terms of sine or cos. This becomes, this becomes 1 plus 1 plus, because this is reciprocal, this is instead of sine over cos, this is actually cos squared x over sine squared x. Okay, now I'm going to stop right there. Okay, we will continue this. This isn't done. Let's look at my right side. Okay, so if I take a look at this, okay, I'm adding two fractions, but my fractions actually don't have a common denominator. This is 1 minus cos x, and this is 1 plus cos x. So I need a common denominator. Okay, you need a common denominator. So because I need a common denominator, okay, I would multiply this side with 1 plus cos x, and I'll multiply this side by 1 minus cos x, and then my denominator would just be these two combined. So my denominator, okay, would be 1 minus cos x times 1 plus cos x. So if that's my denominator, I would have to multiply this numerator by 1 plus cos x, and then 1 minus cos x. Let me just rewrite that. Okay, so there we have these two. Now, if you take a look at this, there's addition in between here, okay? So if you take a look at this, okay, because this is positive cos x and this is negative cos x, they actually cancel each other out, because if I drop the denominator, sorry, if I drop the brackets, actually let me rewrite this without brackets because I don't need to show the brackets because there's addition in between them. Okay, so take a look at this. 1 plus cos x plus 1 minus cos x. So I have like terms. My like terms are cos x. Positive cos x and negative cos x cancel each other out because positive and a negative, or like positive 1 minus 1 is 0, right? So in that case, I'm left with 1 plus, or 1, sorry, 1 plus 1, which is 2, over 1 minus cos x and 1 plus cos x. Okay, so I'm just going to write here, okay, that these cancel out because, okay, positive and negative. Negative cos x and positive cos x, okay? You're subtracting cos by cos. Okay, let's go back to this side before I do anything. Actually, no, let's continue here because I don't want you to lose track of this. Now, 2 over 1 minus cos x and 1 plus cos x. Now, if you take a look at this, just because we're using cos, okay, doesn't mean, don't get confused from that, okay? This should ring a bell to you. 1 plus something and then 1 minus something in brackets. This is something that has been technically factored already, okay? And if you remember, this is actually a difference of squares, okay? I'll do a little side note all the way down here. Okay, this is a little side note. Remember, think of this. 1 plus cos x, okay, times 1 minus cos x. That's the same as saying, let's just say it was written as 1 plus x and 1 minus x. Well, 1 plus x, 1 minus x, that was basically this being written. 1 minus x squared. Remember when you had something squared, this is a difference of squares, you wrote it as 1 minus x squared. So this, when we go back, must be 2 over 1 minus cos squared x, because it is a difference of squares. Okay? Factoring it properly would be when you saw this in your factoring homework, you actually wrote it out this way. Now this is going backwards. You're seeing it this way, and now we're writing it, okay, the way this is. Okay? I know it's a little confusing. Again, it takes time and practice, okay, guys? So, let's go back here. 2, okay? Now, because I'm adding, I need a common denominator here in this bracket, 1 plus cos squared over sine squared. So in order for me to get a common denominator, I would have to multiply this by sine. So this would be sine squared x over sine squared x plus cos squared x over sine squared x, okay? This is going to now give you sine squared x plus cos squared x over my same denominator, which is sine squared x. Now, again, remember, this is your Pythagorean identity. Sine squared x plus cos squared x is equal to 1. So this is 2 times 1 over sine squared x. Okay? Now, 2 times sine squared x, well, if this is a whole number, again, technically over 1, so 2 times 1 is 2 over sine squared x. And I can't simplify this any further, So therefore, let me go back and see what I can do here. 1 minus cos squared x, well, if I remember from my Pythagorean identity, that is actually sine squared x. So this is 2 over sine squared x. So this was one of my Pythagorean identities, okay? That's one of the rearranged Pythagorean identity. And then this was also a Pythagorean identity, which gave us 1, okay? So you must remember Pythagorean identities in order to prove these, okay? Again, I have to state my therefore statement. Therefore, left side is equal to my right side. I have to state my restrictions. In this case, they use x, so I'm going to use x cannot equal, okay? Now, because we had 10 in one of the denominators right here, we're just going to write all the degrees. Cannot equal 0 degrees, 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Okay? So now, your homework is here. It's page 310, questions number 3, 5, 8, A, C, E, F, and 12. Again, try your best, do the best that you can. If you get frustrated, leave it and look at it. You know, give it a 5 minutes, take a break, and then look at it again. Okay? If you have any questions, I am available still on Edmodo. You can go ahead and ask me any questions you need to, and I will try my best to help you. Okay? Good luck. Bye.